we've never got to visit about things we do in life, but I am a pilot, and when you're flying, if you want to take a bunch of people up in a Cherokee 140, you can put 4 people in it if the temperatures are below 30 degrees. But if it's 80 degrees, you better just take the 3, and better take a full runway too to get off the ground. What happens is everything that is compressed by temperature or by barometric pressure also has a play on what comes off of it. So that if it's a colder temperature, that odor molecule is going to be tighter packed, meaning it's going to have more to take in once it gets to a warmer spot. Kind of like anhydrous ammonia will stay liquid as long as it's kept under pressure. But as soon as you release it to the atmospheric pressure, 29.92 or whatever the barometric pressure is that day, it volatilizes off into the gas, and whew, you got ammonia. So here, what we're doing is we're actually taking these molecules that are trapped in that manure, generated like the sun by the bacteria. Now, another good thing is anaerobics, which is what produces the CH4 to that 1/2 of theory, which is fact, that methane is produced by the final stages of breakdown, of decomposition, conversion to finally CH4. As we keep a more positive, when we extract that gas out of there, wow, O2 is gone. Oxygen is gone. We don't breach this tank ever. Because once this gas is pumped off with a vacuum, and on a vacuum you have vacuum and you have pressure. The gases, which are 100% the gas, are pushed out through the pressure side of the vacuum pump. That goes to a low stage tank similar to this one, which it go into this one. This one here, we have the scrubber solution in here, and that's a base, that's ammonia. That ammonia will scrub off CO2, it'll scrub off short-chain fatty acids, hexanoic, butanoic, propanoic, hydrogen sulfide. You've caught them now forming ammonium salts in your ammonia. Now your ammonia is charged as one of the most valuable fertilizers you can put on a crop to make it green and grow, because it's readily available ammonium, not ammonia. Now, as these gases then come through, it would be a pipe that would go to the bottom of the aqueous ammonia solution and would bubble back to the top, because it's a gas, it's going to go down, it's got to come up. As it comes off, there's a low stage compressor on the other side of it, capable of pulling 150 psi of pressure. That 150 psi goes into a tank identical to this, boosted by that compressor to elevate the low pressure generated by the vacuum pump, pushed through the aqueous ammonia solution, now being picked up by a higher stage compressor. That's pure methane. Pure methane. Everything else is screwed off. Nothing else came in. Everything was being produced. Pure methane.
How difficult is it going to be to get our diesel generator to run on methane? That should be pretty simple.
No. Hey, you got a hose, and you got a tank of methane, and you got a gasoline engine, cut the fuel line, stick the hose in the carburetor, fire up.
What about a diesel engine?
Diesel engine, I don't think you can go there.
Okay.
Because diesel requires oil for lubrication.
Yeah.
Diesel also requires high compression for combustion.
Yeah.
And a gas of that nature, you'll burn her up.
Yeah.
Yeah, it'll never run on it.
Our generator over at 286 is propane.
Yeah, but it's not diesel.
No.
Right.
Oh.
It's a propane generator.
Yeah,
I don't know. Do you guys know if the Samson?
He was asking about a diesel.
I assume that the Samson.
That's gas.
It's gas?
I'm sure it is.
Oh, okay.
Yeah, I'm sure
probably natural gas.
Oh, I think it is, because you got propane there.
Yeah.
It may even be propane.
Okay.
Propane, natural gas all convert.
Yeah.
Yeah, you can do that.
Okay.
No, the good thing about natural gas is it runs on a whole lot less inches of water column.
Yeah.
You have to have at least 10 pounds with propane, and with methane about 3.
Okay.
3 inches. 3 inches, not 10 pounds, but 3 inches. There's a difference, you know.
You know, just in your project, if you wouldn't mind reaching out to Jeremy, or when you're up there, just check out that generator and see what you think.
Sure.
Because I think
it's a nice generator.
Yeah. Yeah.
It's a big one.
Yeah, it's a big one.
It's a big one.
Yeah.
Yeah. So anyway, the good news is now that we got that gas over here and we got a higher pressure over there, if you take a syringe and you stick it into a vial of chemical, and you draw down on that syringe, you fill it with what's inside the vial, right?
Yeah.
But you don't want any air in there, because if you do, you're going to have to flip the air out. We don't want any air at all. So So what we've done is we've got, let's just say now this tank's the collection tank.
Yeah.
Then we've now got that compressed air, and we've got up to 150 psi of air pressure, gas pressure, excuse me, no air pressure, gas pressure here. We got a tank here that got 1/3 mass inside of it. We got to get rid of that mass, but we don't want no air. What do? Take the gas pressure that we collected and we pressurize this vehicle with the methane, which of course only the gas, because when the syringe hits the end of the plunger hits the end of the syringe, I should say.
Yeah.
That's as far as it goes. The same way here, when the liquids exit, not before they get out of the pipe, but once they get to the pipe, then the pressure stops. There's no blowout. We don't want to blow methane into our pit. Not that it would bother us, we'd always pick it back up. But we want to stop it at an empty reservoir. Now the process, all controlled by computer, reactivates itself to start all over again. And when it does, the same process. Now what you're doing, let's do this.
What powers the plunger to create the vacuum, or the vacuum?
The vacuum actually does it all.
Is it run by electricity?
Yes, sir.
Okay.
It is. Now that can be a 240 volt, 15 CFMs, but let's do a little mathematics.
Yeah.
In every cubic foot, there is 7.48 gallon of liquid, okay? So a gas measurement, that 7.48 occupied by a cubic foot is similar to what you can associate to the volume of accumulation. So if you're doing that 15 cubic feet per minute, that's 15 times 7.48 per minute. And I'm going to let you do this when you get the video back where you're going with it. Multiply that times 60, and then apply that. You're going to find out we're going to exceed 40,000 cubic feet by about 19,000 cubic feet in a 24-hour period. We're going to overproduce what he is doing with his naturally aspirating out of the manure into his little collecting agent that he has. And I'm not knocking the guy. I respect him tremendously because his data gives us grounds to base our facts on.
Yep.
His facts that he's put out there in literature for us to read. But doing the CFM performance, that vacuum pump, if it's running and it's rated 15 CFM cubic feet per minute, I guarantee you, Tom, it's pulling 15 cubic feet per minute. It's exhausting 15 cubic feet per minute. If what it's accumulating, it's extracting, and it's pushing, you've got it. It's yours. You own it. Now it's yours to use. Once it's processed through the purifier, or I call it the scrubber. Once it goes through the scrubber, that's pure CH4.
Now, are these tanks exact tanks you're going to use for prototype? These
Only
two
for the prototype.
for the prototype.
When we get ready to do the big guy, we're going to probably have a 3,000 gallon degassification tank. The other thing I'm environmental control, but I'm also interested in making environmental control justified to our farmers. You got to give them something to get something.
Yeah.
If you can't give them something, you can get nothing. But what we got to do is give them a technology that's not only going to get rid of 100%, and I say 99.9, okay, got to be there. 99.9% of their odors we're going to get rid of simply because we got the thing to stink out of it.
Yeah.
Now, once you have mass, and I want to go there, if you take a 5-gallon bucket of motor oil and you put it in the center of your garage, you're not going to smell it. But you will if you're going to stick your nose in it or get close to it, you'll smell the motor oil. If you take your bells off and you walk in a room of people, they're not going to smell your belt until you put it up to your nose. Now, the thing difference between a belt and a bucket of oil and hog gas is its mass versus gas. Anything that is substance has a smell. The smells are only made available to our olfactory system by the gas molecule that carries it. The odor itself is contained in the gas. Once you take away the gas, you're not going to smell your hog.
Yeah.
A pig don't stink. I mean, we're so close to being a pig, it ain't funny.
Yeah.
Our heart, our valves, we sweat, they don't. That's one thing different. But pretty much to the anatomy of that animal, it's so much like our own. And if we can take an animal that don't stink and take away the gases that are generated by his waste product, we got the best of all worlds. But then even better yet, converting that byproduct of the decomposition was aerobic anaerobic bacteria used in the fuel. We have now provided what we call renewable energy that can be used all around the globe. We have cattle, hogs, chickens, even chicken ducks, really ducks.
Yeah.
Yeah, because they do it. Chicken's pretty much dry, but their manure could be used to produce methane. And
That's
it's very
interesting.
basic. It's kind of like putting lime in with the other acids. It's a basic manure.
So what do you think it's going to cost to build the prototype? Have like a vacuum pump, a couple tanks?
Well, the pump, Tom, about $1,200. The valves that we're going to need to put on there. The first company I got pricing with, they were pretty pricey. They were as bad as the pump. But I got another valve company that I can work with, and I might be able to get them down around $600.
Okay.
On that, we'd have some plumbing.
You know, I
to
could
do.
I could see on those valves if I could get wholesale pricing through Siemens. So if you want to give me the specs on them, let me price them out for you. I'll just see if I can get them cheap.
Through Siemens.
Yeah, because
You want to see? Well, I'll tell you what I want to do. I want to take you up and I want to show you this U.S. pump. If we've got the time.
Yeah.
Because I know your schedule and I
Yeah.
respect it, but let's go up there.
All right.
And dude, I think I got enough here for you guys.
So if you had a ballpark, just a retail for
For the
the
prototype,
yeah for the prototype.
I'll keep it below. Let's just do this. I'll do it at 5,000.
Okay.
Okay.
All right.
And have you some methane.
All right.